In today's video, we will start with the question 13. The table below shows the pollutant standards index of city X and city Y, measured in the same period of 10 days. A higher PSI reading indicates poorer air quality. So here we have given in the table for city X. First, we have to arrange the data values in the ascending order. So we start from the smallest value. Here we have 16, 21, 23, 27, 23, 37, 50, 53, 65, 80, 81, and 100. So we have the 10 values of the data set. Now for the PSI data of city X, we have to find in the part A the range. So to find out the range, we will use the formula largest value minus smallest value. So first we have to identify the smallest value, and that is 16, and the largest value, and that is 100. So we will subtract 16 from 100, and it will give us the range of 84. Now for the part B, we have to find out the median for the city X. So for this, first we have to check the number of data set values. Since the data set values are even in number, so the median will be the mean of the two middle values of the data set. So the two middle values are 50 and 53. So here, somewhere here, median lies between the two middle values. So now to find out the median, we will take the mean of the two middle values of the data set. So here we have 50 plus 53 divided by 2, and it will be equals to 50 plus 53 is equals to 103 divided by 2, and it will be equals to 51.5. So the median for the PSI data of city X is equals to 51.5. Now in the part C, we have to find out the interquartile range. So to find out the interquartile range, we have to find out the lower quartile and the upper quartile first. Now we can see that median divides the dataset values in two equal parts. So for the left hand side on the median, the first 5 values are making the lower half of the data, and the other 5 values on the right side of the median shows the lower half of the data. So the middle value of the 5 values on the left side of the median is 23. So the lower quartile Q1 is equals to 23. Now to find out the upper quartile, we have to analyze the upper half of the dataset values, or the right side 5 values lies right side on the median. So the middle value of the 5 values on the right hand side is 80, so this will be the upper quartile Q3. So the value of the upper quartile Q3 is equals to 80. Now to find out the interquartile range, we will use the formula Q3 minus Q1, and we have find out these two respective values. So we have 80 minus 23, and it will gives us the value 57. So the interquartile range for the PSI data of city X is equals to 57. Now in the part 2, for the PSI data of the city Y, we have to find out in the part A the range. So first we have to arrange the data for the city Y in the ascending order. So if we will start with the smallest value, here we have 79, 99, 103, 114, 121, 171, 198, 200, 235, and 308. So now to find out the range, we have to mark the largest and the smallest values of the data. So the smallest values is 79 and largest value is 308. So the range will be equals to largest value minus the smallest value. So the largest value is 308 minus the smallest value, and that is 79. So we will get 229. So the range for the PSI data of city Y is equals to 229. Now in the part B, we have to find out the median. So since we see that the data values are even in number, so the median will be the mean of the two middle values. And since the two middle values are 121 and 171, so here we have the median Q2 somewhere between these two values. So now we will get the mean 121 plus 171 divided by 2, and it will be equals to 146. So the median for the PSI data of the city Y is equals to 146. Now in the part C, we have to find out the interquartile range. First we have to find out the lower quartile and the upper quartile in order to find out the interquartile range. So since we can see that the median divides the dataset values into two equal parts, so the 5 values on the left side of the data and 5 values on the right side of the median. So the middle value of the 5 values left side of the median is 103, and that is the upper quartile, lower quartile Q1. So the value of the lower quartile Q1 is equals to 103. Now the middle value of the 5 values on the right side of the median is 200. So it is the upper quartile Q3. So the value of the upper quartile Q3 is equals to 200. And since we know that to find out the interquartile range, we will use the formula Q3 minus Q1. And the values of these two quartiles we have already found out. So 200 minus 103 will be equals to 97. So the interquartile range for the PSI data of city Y is equals to 97. 3. Which city's data show a greater spread? Since the interquartile range for city Y is greater than the interquartile range for city X, So the city X shows. So the city Y show the greatest red. In the part 4, compare and comment on the air quality of two cities. Give two reasons to support your answer. So city Y has a poorer air quality because its median PSI reading is much higher than city X. This is the first reason. Now city X air quality is generally more consistent because its interquartile range is smaller than city Y. Now in the question 14, Imran has written down 7 integers. The mode of these integers is 19, the median is 10 and the lower quartile is 8. The smallest integer is 10 and the largest integer is twice the upper quartile. List the integers in set notation in ascending order. So first we will write down. It is given that there are 7 integers. And we have to arrange them in ascending order. The positions of the lower quartile, median, and upper quartile are as follows. So now we will write down here the 7 positions. Here we have 1 position, 2, 3, 4, 5, 6, and 7. So the median will be the middle value since the total frequency here n is equals to 7. So the median lies somewhere here. Since median divides the 7 integers into 2 equal parts, so on the left hand side of the median we have 3 positions, and on the right hand side of the median we have also 3 positions. So the middle value of the 3 positions on the left hand side of the median is the lower quartile, and the middle value of the 3 positions that are on the right hand side of the median, the upper quartile. And now it is given that median is equals to 10. The lower quartile is equals to 8, and the smallest integer is equals to 3. So now we will fill in the given information in the respective positions. So on the first position we have the smallest integer, and that is 3. And since the lower quartile is given, so we will write down at the second position 8. And the median is also given, and that was 10, so we will write down at the fourth position 10. Now we are going to move to the information given regarding the upper quartile. Since it is also given that mod is equals to 19. And since we know that the mode is the value that appears most frequently in a dataset, so mod has to be occur at least twice, and it must be in the 5th, 6th, or 7th position. Since it is larger than the median, since we know that mod is larger than the median, so mod should be occur at 5th, 6th, or 7th position. Now since it is also given that the largest integer is twice of upper quartile. So the largest number cannot be 19. So the largest number or the largest integer cannot be equals to 19. This 19 occupies the fifth and sixth position of. So there is only two possibilities left for the mod, and those are fifth and sixth positions. So thus 19 occupies fifth and sixth positions. So we will write down 19 at the fifth and sixth positions now. And of which the sixth position is upper quartile. And since it is given that the largest integer is equals to the 2 times of upper quartile, and since we have find out the value of the upper quartile, and that is 19, so 19 multiplied by 2 will gives us 38. So the largest integer is equals to 38, and we will write down here in the seventh position the largest value. So now since the mod is 19, since mod is equals to 19, so no other integer can appear twice. So the only integer between 8 and 10 is 9. So in the third position we will write down 9. Now the set notation, now the integers in the set notation in the ascending order will be look like 3, 8, 9, 10, 19, 19 and 38. Thus this is the integers listed in a set notation in ascending order. Now in the question 15, the duration in hours that 40 students slept for on a Wednesday night were recorded. The cumulative frequency curve shows the duration, T hours, and the number of students who slept for at least T hours. So in the part 1A, estimate the lower quartile, upper quartile, 40th and 80th percentiles of the duration that the students slept for. So first we have to understand the scale along x-axis and y-axis. So for x-axis, since we can see 2 points 4 and 3, so here we have 4 minus 3 divided by total number of squares between these 2 points, and that is 5, and it will be equals to 1 over 5, and it will be equals to 0.2. So its square unit along x-axis is equals to 0.2. Now the scale along y-axis, we have 2 points 5 minus 0 divided by total number of squares, and that is 5. So 5 divided by 5 will be equals to 1. So each square unit along y-axis is equals to 1. Now to estimate the position of the lower quartile from the cumulative frequency curve, we will use 3 by 4 n. So here we have 3 by 4, n is equals to 40, and we will cancel out with this and we will get 10. So it will be equals to 30. Now from 30 we will draw a horizontal line until it touches the cumulative frequency curve. Now from the cumulative frequency curve we will draw a vertical line until it touches the horizontal axis. Since we have e square not equals to 0.2, so we have 5.2, 5.4 and 5.6, and between 5.4 and 5.6 somewhere 5.5 lies. So the value of the lower quartile Q1 is equals to 5.5 hours. Now to find out the upper quartile, to estimate the position of the upper quartile, we will use n by 4, and it will be equals to 40 over 4, and it will give us 10. So from 10 we will draw a horizontal line until it touches the cumulative frequency curve. Now from the point of intersection on the curve we will draw a vertical line until it touches the horizontal axis. So we get the value 7. So the value of the upper quartile is equals to 7 hours. To find out the 40th percentile, we will find out the 40% of the total frequency, and then that was 40. So 40 over 100 multiplied by 40 will gives us 16. Now we will look the data value corresponding to the cumulative frequency of 16. So from 16 we have 16 somewhere here. We will draw a horizontal line until it touches the cumulative frequency curve. Now from the point of intersection on the curve we will draw a vertical line until it touches the horizontal axis. So here we have the value 6.2, 6.4. It is approximately 6.4. So the 40th percentile will be equals to 6.4 hours. Now to find out the 80th percentile, we will find out the 80% of the total frequency n. So here we have 80 over 100 multiplied by 40, and it will gives us value 32. Now we will look the data value corresponding to the cumulative frequency of 32. So from 32, here we have 32 somewhere here. We will draw a horizontal line until it touches the cumulative frequency curve. Now from the cumulative frequency curve, we will draw a vertical line until it touches the horizontal axis. So we have the now here we have the value 5.5, 5.2, 5.4. So between 5.2 and 5.4 we have the value 5.3. So the 50th percentile, so the 80th percentile is equals to 5.3 hours. For part 1b, estimate the interquartile range. So to find out the estimated value of the interquartile range, we will use the formula Q3 minus Q1, and since we have found out the estimated values and those are 7 minus 5.5, so the estimated value of the interquartile range will be equals to 1.5 hours. Now in the part 2, find an estimate of the fraction of students who slept for less than 6 hours. But since the data in the commuter frequency curve given in the at least form, so from the graph, the number of students who slept at least 6 hours for this, we will draw a vertical line from the point 6 on the horizontal axis and until it touches the commuter frequency curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. So here the value is approximately 24. So the number of students who slept at least 6 hours is equals to 24. But we have to find out the number of students who slept less than 6 hours. And we can find out the number of these students by subtracting the number of students who slept at least 6 hours from the total number of students. So the total number of students is 40, and the number of students who slept at least 6 hours, and that is 24, and it will give us 16. So 16 students slept for less than 6 hours. Now to find out the fraction of students who slept for less than 6 hours can be found out by the number of students who slept for less than 6 hours divided by total number of students. So we have 16 divided by 40, and with the table of 2 we have 2 8 is 16 and 2 20 is 40, and here we have further simplification, 2 4 and 2 10 is 20. Further simplification gives us 2 2 is 4 and 2 5 is 10, so it will be equals to 2 over 5. So the fraction of students who slept for less than 6 hours is equals to 2 over 5. In the part 3, if two students are selected at random from the 40 students, find the probability that both students had a duration of sleep that was between 6 and 7.2 hours. Since we have found out the number of students who slept for less than 6 hours, and that was 24 from the part 2, and now we have to find out the number of students who slept for at least 7.2 hours. Now from x-axis we have 7.2, since each square unit along x-axis is equals to 0.2. So here we have drawn our vertical line until it touches the commuter frequency curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. So here we have the value approximately 8. So the number of students who slept for at least 7.2 hours is equals to 8. But we have to find out the number of students who had a duration of sleep that was between 6 and 7.2 hours, and that will be equals to 24 minus 8, and it will gives us 16. So the number of students who had a duration of sleep that was between 6 and 7.2 hours is equals to 16. Now we have to find out the probability that both student had the duration of sleep that was between 6 and 7.2 hours. Now since we have to find out the two students at random, so the probability for the first student who had a duration of sleep that was between 6 and 7.2 hours will be 16 over 40 divided by total number of students. We will use the formula of probability here. So the number of favorable outcomes in this case is 16 and the total number of outcomes is 40. Now for the second students who had the duration of sleep that was between 6 and 7.2 hours, so we have already selected one student, so the total number of students to remain will be 39, and the total number of students who had a duration of sleep that was between 6 and 7.2 hour will are left will be 15. Now with the table of 2, we have 2 8 is 16 and 2 20 is 40. Again we have 2 4 is 8, 2 10 is 20. Further simplification gives us 2 5 is 10 and 2 2 is 4, and this 5 gives us 5 3 is 15. So we have 3 2 is 6 divided by 39. Now with the table of 3, we will further simplify with 3 2 is 6 and 3 1 is 3 and 3 is 9. So we have 2 over 13. So the probability that students who had a duration of sleep that was between 6 and 7.2 hours is equals to 2 over 13. Now in the part 4, a student claims that only 10% of the class had a duration of sleep that was between 6 and 7.2 hours. Comment on whether the above data supports this claim. So in the part 4, percentage of class who had a duration of sleep that was between 6 and 7.2 hours is equal to 2 over 13 multiplied by 100%, and it will gives us the value 15.4%. So 15.4% of class had a duration of sleep that was between 6 and 7.2 hours. So the above data does not supports the claim
that only 10% of the class had a duration of sleep that was between 6 and 7.2 hours.